This classical assumption is referred to as no serial correlation of the error term. It's also sometimes called no auto correlation. We're going to use them interchangeably. Historically, one of these terms referred to the correlation of the errors with one another in time series data, and the other term referred to correlation of the error with one another in cross-sectional data. Nobody really distinguishes between the two anymore, and frankly, I can never remember which is which. So we're going to use them perfectly interchangeably. No autocorrelation, no serial correlation means the same thing. Violating this means that the error term from one observation in our data set tends to be correlated systematically with another error term. And typically we're going to be able to detect this more readily in time series data. And what that means is that over time, error term observations are going to be correlated with proximate or contiguous error term correlations. That is, the error term from time period t plus 1 is going to be correlated with the error term from time period t. Okay, now that's pretty abstract, given that this error term itself is pretty abstract. So let's try to see if we can get an intuitive feeling for what this might look like. So let's suppose that we have disposable income. I'll use YD to denote disposable income here. And we have household consumption on the vertical axis. And I'm imagining that we have time series data. I'm also imagining that over time, disposable income has a tendency to rise, okay? And we have a regression model which says CT equals beta 0, there's beta 0 here, plus beta 1, slope of this thing is beta 1, y dt plus epsilon t, okay? The deterministic part of that is this, so the lines equation is that, okay? So we have a model that's going to predict consumption based only on our disposable income values. But we know that there are other things that could be driving consumption. For example, households are sometimes more optimistic and sometimes they're more pessimistic based on what they're observing in the world around them. So if we have some good news, right, happening around this time period, and we then follow that, it seems, with a bunch of consumption values that are above what we would have predicted based on disposable income alone. The optimism wanes at some point, and we end up with a cluster of data points that sit below the line, and then the optimism comes back, and we have consumption values that sit above the line. Well, when the observations of consumption are above the line, we're looking at stochastic error values that are bigger than 0. Here we're looking at stochastic error values that are less than 0, and here they're bigger than 0 again. Okay. Remember, the distance between a data point and the line itself is just the stochastic error. So a pattern of data points like this, where we have clusters above the line, clusters below the line, and clusters above the line, again, would be evidence of a violation of no autocorrelation, no serial correlation. Okay. When this problem arises, we're going to see that it messes up our estimates of something called the standard error of the coefficient, which in turn is going to disrupt our ability to conduct hypothesis tests about the value of these population parameters, beta 1 and beta 0. So it's going to be a problem, but we're going to assume for the time being that we don't have the problem. I'll give you one other example of how this could arise. Okay, if I put an x here and a y here, and I'm going to imagine a kind of inverted quadratic relationship, inverted parabola of data points in a scatter plot. And if I try to fit a linear regression to that scatter plot. It might look something like this. Once again, I'll have clusters of negative stochastic errors followed by a cluster of positives followed by a cluster of negatives. And I've created that problem myself by picking the wrong functional form. Okay? Of course, if I have the model correctly specified, I have all the right variables in there, I've picked the right functional form, this problem won't arise, right? But it is another way in which you could generate a violation of this particular classical assumption.